I'm Vesa Leppänen, CTO of Arbonaut, and most people already know. And today I'll talk a little bit about use of open data in operational decision making, in field operations. And I start by mentioning that Finland is in a special position today in this open data. Finnish government has understood that data is infrastructure like a road or power line, and it provides such data, for example in LiDAR, format of LiDAR and forest information to anybody who wants it. And this has made Finland, like from our perspective, a laboratory of testing and bringing new analysis products on top of that data to the market, which we can then export to different countries where they don't necessarily have the open data, but there we have to then organize how to collect the data. So if you want to develop something that's based on LiDAR or imaging or databases of forest resource, the best place today is Finland. How does this go forward? So this is the necessary 30-second propaganda about Arbonaut. So you can see just a little bit of LiDAR data from a power line over here. This is what we use a lot in our analysis as raw materials. And then a couple of things that we do. On the upper right corner you can see a little bit of information about operability of forest terrain. On the lower left corner you see a little bit of data from a eucalyptus plantation, and you see in the corner there actually stands that are automatically generated, and that's one of our products that we do in volumes. And then on the lower right corner you can see some fire management data. That's actually patent pending. So there's an approach to protect houses and infra from forest fires by classifying the fire fuel path that leads to a house. Today I thought I'll talk a little bit, sorry I put this, a little bit more detail in road trafficability for timber transport. This is one of the analyses we have been working together with Metsäteho. And actually Pirjo will talk a little more about need for this product in the next presentation. So here we actually, why I took this as a sample here, we used many kind of pretty complicated analysis from different sources of information that's open to produce the trafficability of the road. So here we are looking actually a little bit of the data in our PROMS web viewer. This is a way how you can access the data if you want to. You just get a subscription to this and then go through internet browser to see the data anywhere you want. And I'm looking one open data layer by itself. You can see Maastotietokanta, which is the Finnish national mapping database, visualized by Arbonaut. So oftentimes actually when you use open data, the open data itself is maybe not that usable as it comes. There's lots of downloading and cleaning and then analysis work before it's a product. So how the open data serves here, when the price of the raw material is zero, the price of the product also is lower to the entire market. There's still a price because somebody has to go and do a lot of product development to make it workable, and then analyze it and put it to the server and cover normally the entire country. That's the idea. And actually here you can see the black roads, and you can see red and yellow areas that are areas where you have reduced operability during the wet season. And we can go a little more detail what goes into this data. So the end product is pretty easy and simple. If you, for example, plan to extract timber from that area, here you can see on a map that, okay, this timber has to be accessed through a road that's probably not operable during the spring season. And if you see that red, that's what it means. So then you pay more attention to the road access. You think, okay, maybe I need to gravel it, or maybe I need to at least go see it if it's too wet to run. So now, here we are looking one piece of this information. So you see that yellow triangle there. So you are actually standing in the corner of that triangle in the road and looking to upper right corner, and the view that you see is what taken from the field on that location. So as a hunter, I would say if it's wet season, this road is kind of iffy. You can drive it, but there's a risk that if you drive with a family car, you'll sink it. Well, if you drive with a timber truck, let's say 15 times, there's much higher risk that you sink it. It is identified as red. This data is now shown on another data layer derived from open data. You see the Forest Operability Map, and that can be explained. Blue is wet and red is steep. So that tells where you can drive harvesters and forwarders in the forest. Here we look at the same data, just looking at the tree height on top of it. Here's another layer of open data that is useful. So this is now the soil map. Finland has been covered with 1 to 200,000 soil map, which is a little bit crude for many uses, but then good part of the country is actually covered with 1 to 20,000 mapping, and this is example of that. Very useful open data for many forest operations, for example, deciding which trees should I plant next. All this data, like the wetness, vegetation height and its shading effect, and the soil goes into the analysis where we get the road trafficability. Here is another type of analysis that we have automated, and also that's patented already about 10 years ago. It's the drainage management. So we use the low density LiDAR data and analyze how deep are the ditches. And here you can see roadside ditches that are automatically detected, and you can actually, the ditch depth is a big factor in deciding if the road is operable. If there's good ditches and it's well drained, it's probably better operable. Also the purple dots tell about the volume of water that goes through it on certain standard rain. That is taken also from open data. So we look at the basin that collects water to that spot. Shading, or actually sun accumulation layer, that also affects the roads. If you have lots of shade, for example spruce trees, the road is not drying that quick in the spring. And here now we finally look at the product. This is actually another location. So you see the triangle, we are standing on the road and looking towards that curve, and this photo is from the location. So that's another place that was identified as probably soft during the spring season. As you can see, there's no drainage. It's on a field. There's water accumulated to it, so it is. If you drive this on springtime, you have a high risk of sinking in. And then, just to see another view of the data, all the data that we put in Prompt system is also available through Prompts Mobile, where you can see yourself and your tail, and then access all the data at the location where you are going. So now, after looking a little bit on this one case in more detail, where we saw many different layers come together and then just put the color on the road. Okay, is it going to be wet or not? We look a couple of other cases or derivatives of the open data. So some of the data sets are actually quite as they are available as open data, and some of them have sophisticated analysis in it. This is one of the examples where there's a lot of analysis in it. This is the seasonal operability of the soil itself or the terrain. So this map is having increased use in the industry and forestry sector. So here you can just look at, okay, what season can I make a logging work in this area? It also contains analysis about the drainage condition, depth of the ditches, about the water accumulation, about the soil type, and so on. Here's another type of data set that may be practical in operations. This is the pre-harvest clearing need. So here you can see the density of the understory in the forest. So this is taken from the LiDAR data and analyzed just to explain how well do you see under the trees. This is something we developed internally in-house, and it's available as a product. It's practical if you are planning a logging operation and want to see that, okay, do I need to do pre-harvest clearing on this site? And this has been tested, it works, and it's very reliable. Here is the same data on same area on aerial photo. So you can see the densest areas here are the young plantations. But sometimes you can see that under big trees there's also bad visibility, which means that pre-harvest clearing need is there. This is some data that cannot be done with any other method but LiDAR, because LiDAR is the only method that can see under the trees. Okay, this may be coming back to the same, but this is the Finnish National Land Surveys database visualized. Here we are looking actually some of the open data from forest centers. So if you're looking for here you are looking volume of the stands, cubic meters per hectare, and we have visualized over our visualization of land survey mapping. This kind of data can also be accessed over entire Finland through Arbonaut systems. It can be practical if your work is just, for example, finding timber. Here's the development class. Here are actually the key habitats from the forest center data. These three layers are exactly as they come from the forest center server. And here are, well, this translation is quite free, forest use announcement filings from the forest center open data. These are by stand. So basically it's called, in Finnish it's called metsänkäyttöilmoitus. So you can see, thank you. My translation was freehand.
I don't know. This is
Good.
what we use. I don't know.
Very good. And also some single species stands to see where you have just one species on a stand. So I gave this as a just bit open-ended ideas as teasers to think that how could I use some of the open data or derivatives in my operations. Thank you.
I suppose you are using your own drone equipment and cameras. Is it so?
We are not having any sensors ourselves. Our strategy is to concentrate on the customer's data need, information need, and then collect all the information from partners.
Okay. Good.
Any other
question. So you said that there is you get the information from some other third party. So is this information, how to say, accurate enough? So do you need more accurate information?
We focus a lot on the sensing part itself, even if you don't own the sensors, but we actually quite actively develop and work on it. Our thought is just that we don't invest in a sensor because that would turn us into a sensor capacity selling business instead of listening what the customer needs. Then we would need to sell the sensor that we developed. So we are very intimately talking and specifying and working with many kind of sensors, so we know them. The idea is just that we don't bet on one sensor, because we would need to bet on so many different sensors and invest so that we would be like a big storage of different sensors. So there are different companies who do that, but we get what we need.
So if you have now the chance to point out that what is the most promising sensor what you would like to develop and what kind of information you would like to take from there?
Personally, this would be an open discussion. Even in Arbonaut you would get different answers. We have these discussions. Personally,
Go ahead.
Personally, I would take the spectral LiDAR sensor, because that has such a huge capacity to tell about the type, kind, species of vegetation, and every day it will do the same answer, no matter what the weather is and what the conditions are. So you don't need to worry about if the sun is up or down. With active spectral sensing, you know what's there, and you can fly day and night.
So Jouni, my colleague, what do you think about this situation, that there is a need for spectral information?
Spectral LiDAR.
Spectral LiDAR, okay.
Spectral LiDAR means that you have lasers with different bandwidths, and they shoot like green and red bandwidths. Yes. So that's active sensing instead of passively recording what sun is sending up.
Sari Tasa from Ministry of Economic Affairs. I'm a big fan of Arbonaut work.
Thank you.
And it was the first things I learned about photonics and forest work in Joensuu area. Maybe that's the reason. But you explained here the work that you have been doing in Finland. You do work also somewhere else, right? And what kind of export product you are?
Here, the audience is mostly Finnish, and even if not, I think the same kind of ideas would be interesting. But we work quite a lot on plantations, eucalyptus, radiata, and others. We work quite a lot on carbon mapping in tropical countries, especially. We work in IT systems as well. Currently, there's work in Pakistan going on about forestry IT system. But basically, what we do, Finland is a lab where we develop it, and then in many cases we go with a derivative of that into the different markets globally.
So as it was asked, the question about technology. So what are the laser wavelengths are used in these LiDARs, and what you said that different spectral LiDARs are required. So what are the wavelengths range?
164 nanometers, the infrared, is the traditional LiDAR sensor that has been used for 2 decades. Yes. Today there's green bands 530, if I remember right. Yes, and then there's 1550 nanometers. That's a bit more further in the infrared. So those are the areas where today there's powerful lasers enough to do lasing. Green is a little bit of a problem because it's eye visible, so it's not naturally eye safe. So you have to work on the intensity a lot to be safe.